Hello and good day. We are from course BDA 30603 Heat Transfer, Section 5, Group 2. In this video, we will be conducting a few experiments to explain conduction, convection, and radiation. Now, let's start by introduce ourselves one by one. My name is Junlin Jaji.
I'm Saraswati Alaika. My name is Yimichi.
My name is Ong Kang Nan.
The first experiment we will be doing is about conduction.
First of all, what is conduction? Conduction is a heat transfer within the material or in between the material which are in direct contact. Heat flows from the higher temperature to the lower temperature. Basically, metal is a good heat conductor. In this experiment, we will place the butter on the spoon and it melts. So, here we will see the heat is transferred.
These are the apparatus for the conduction experiment. We have hot water, 2 spoons, one is made of metal, one is made of plastic, a cup, and butter.
So let's start our experiment. So for the first step, we need to put a scoop of butter on these two different material of the spoon. And then put in this cup and pour the hot water. And wait for a few minutes.
After a few minutes, we can clearly see that the butter on the metal spoon starts to melt quickly as it transfers heat efficiently from the hot water to the metal spoon to the butter. The butter on the plastic spoon melts slowly because the heat transfer is not efficiently from the hot water to the plastic spoon and then to the butter. From the result of this experiment, we can conclude that metal spoon is a good heat conductor and plastic spoon is a poor heat conductor. This demonstrates the varying ability of different material to conduct heat.
So in the previous experiment, we have solved how the conduction works. So now we will conduct the experiment for convection. So what is convection? Convection is the movement of heat of the liquid or gas where the warmer part will go up and the cooler part will go down. It also means that the warmer part is less denser than the cooler part of the gas or liquid.
These are the apparatus for the convection experiment. We got hot water, a plastic jar with water in it, a cup, and also food coloring.
Now we start an experiment. So first we fill the plastic jar with water and we add a few drops of food coloring matter. Next we fill this cup with hot water. After that, we put this color water on the top of the hot water. And we will see the result after a few minutes.
So in conclusion, the warmer part goes up and the cool part sinks. This happens because of difference in density. Food coloring helps to show the convection current flow clearly. So in conclusion, this experiment effectively illustrates the convection flow eclipse. Thank you.
Lastly, the experiment we do is radiation experiment. So radiation is basically the transfer of energy through electromagnetic wave. Unlike conduction and convection, radiation does not require a medium and can occur through a vacuum. We demonstrate this radiation experiment by using the toaster to bake the bread. When the toaster is turned on, the electrical energy inside heat up the metal element and causing them to emit infrared radiation. The bread placed inside absorbs this infrared radiation and causing the bread to heat up and undergo physical changes such as browning and toasting.
So that is the apparatus used in this experiment, which are bread and the toaster.
At first, we have to switch on the toaster and then take a slice of bread, put it into the toaster, and then we toast it. Wait until it pop out and then we see the result.
The result, as you can see, the toast is totally toasted by the toaster. Just now, when we turn on the electricity of the toaster, the heating element inside of it emits infrared, which is absorbed by the surface of the bread, and resulting in a toasted color and taste. To summarize up, the primary mechanism of a toaster is radiation. This practical example shows us the everyday use of radiation in our life. Thank you. That's all from our group. Thank you for lending us your ears. Bye.
Don't forget to subscribe, like, comment.
Okay.